Calculus examples, the chain rule. This is video 17. In example 3, y equals e to the 3x plus 1. To review the above videos, you should pause this video now. All videos have been written and produced by Michael J. Bankhead. Example 3 from Part 1 of Video 13. Find the derivative of the function y equals e to the 3x plus 1. Note that the exponent of e is also referred to as a function of x in this video. Solution. You should try method 1 first. Then complete the exercises in scene 3. If you have difficulties with method 1, complete method 2. Then try method 1 again. See reminder 1 in scene 8. Method 1. A direct method. The chain rule is the only differentiation rule that allows you to write down the derivative directly from the function you want to differentiate. The function is y equals e to the 3x plus 1. The function y is e to a function of x. The derivative of y equals dy by dx equals the right-hand side of y, which is e to the 3x plus 1. So bring down e to the 3x plus 1. Multiplied by times the derivative of d by dx of the exponent of e, which is 3x plus 1. So substitute 3x plus 1. Therefore, dy by dx equals bring down e to the 3x plus 1 times d by dx of 3x plus 1 is 3, and thus dy by dx equals move 3 to the front. 3, now bring down e to the 3x plus 1. The instructions above were first introduced in video 14. Now complete the 4 exercises in scene 3 using this method. In each question, write down the derivative directly from the question, omitting the line of working between them. To review the above working, you should pause this video now. Exercises. Applying method 1 to functions that involve e to a function of x. write down the derivative of all four of the following functions using method 1 in scene 2. If you write the above questions on a piece of paper, then display method 1 in scene 2, you can use it as a template to find the derivatives. To find each derivative using method 1 before seeing the answers, you should pause this video now. To simplify each derivative before seeing the final answers, you should pause this video now. To review the questions and answers, you should pause this video now. A general formula that finds the derivative of y when y equals e to a function of x. A general formula to find the derivative of y exists when y equals e to a function of x. Let y equals e to the u of x, then y equals e to a function of x, which is u of x. U of x is also the exponent of e. The formula is found using the statements in scene 2, which were originally obtained directly from the chain rule in video 14. They are shown below, followed by the general formula. The derivative of y equals is dy by dx equals the right-hand side of y is e to the u of x because y equals e to the u of x. Multiplied by is times. The derivative of is d by dx of the exponent of e is u of x. So substitute u of x. Therefore, the general formula is which can be written as dy by dx equals e to the u of x times du by dx, or y dash of x equals e to the u of x times u dash of x. Now complete the exercises in scene 3 using one of the above formulae. As in method 1, write down the derivative directly from the question. Note that, if necessary, you must simplify the derivative. To review the general formula, you should pause this video now. Finding the derivative. Method 2. A set procedure. The chain rule is: so before the chain rule can be applied, the function z must be identified. Identify the function z. Fact 2. If y equals e to a function of x, then z is the exponent of e. Note that the function of x is the exponent of e. The function is y equals e to the 3x plus 1. So y equals e to a function of x, which is 3x plus 1. Then z is the exponent of e, which is 3x plus 1. Therefore, z equals 3x plus 1. The fact stated above was first introduced in video 14. To review the above working, you should pause this video now. The set procedure. I created the following set procedure so that once my students had identified z, they would always be able to obtain the correct derivative. See Reminder 1 in Scene 8. The question is: from Scene 5, z equals 3x plus 1. Then y equals, since z equals 3x plus 1, e to the 3x plus 1 becomes e to the z. So dz by dx equals the derivative of 3x plus 1, which is 3, and dy by dz equals the derivative of e to the z, which is e to the z. The chain rule from Scene 5 is: so dy by dx equals dy by dz is e to the z, because dy by dz equals e to the z times dz by dx is 3, because dz by dx equals 3. Therefore, dy by dx equals, move 3 to the front, 3. Now replace e to the z with e to the 3x plus 1, because z equals 3x plus 1. You should complete the exercises in Scene 3 using Method 2 now, and then try Method 1 again. To review the above working, you should pause this video now. Once you understand Method 1 in videos 15 to 19, you will be able to find the derivative of any other function that requires the chain rule. because every function you will have to differentiate will be similar to one of the functions in these videos. Most of my students were able to use method 1 very soon after I started the topic, and with practice you can too. However, if you have difficulty understanding method 1, then work through method 2 first. In this method, you must first identify the function z in the chain rule formula. This is explained in scene 5. After you have identified z, you can complete the set procedure in scene 6. See reminder 1 in scene 8. When solving questions from your textbook similar to the example in this video, you will find it helpful to display scene 2 for method 1 or scene 5 followed by scene 6 for method 2, so you can use them as templates to find the derivative. If you prefer to find a derivative using a formula, you will find it helpful to display the general formula in scene 4. You should then find this topic simple and beautiful. Cheers! Do not forget to check your answers with the answers in the back of the textbook. Reminder 1 displayed without commentary. To review the above reminder, you should pause this video now.